Let's see if I can get that to work. There we go. Let's see if I can get that to work. There we go. Let's see if I can get that to work. There we go. Testing if I can get rid of the echo. There we go. Testing if I can get rid of the echo. There we go. Testing if I can get rid of the echo. If I take the mic and I turn it on. If I take the mic and I turn it on. Oh, I've got the Twitch stream in the background. That's what's going on. That's my own stupidity. All right, now if I turn on the desktop audio, it should just still work. All right, I'm gonna go through a little bit of a dry run with folks who are actually here. We'll see what we can actually get to work. Testing to see if I can draw. That seems to be up and operational. That's working. If I can turn off the drawing and go in close, that works. And if I can keep all the Twitch built-in stuff going while I'm doing that, that looks right. Coding with the built-in camera. Seems to be up and running. And if I can do that with the sketches and drawing markers. All right. I think we might actually have all the things. Testing my little standby screen. I need to kill a couple of audio loops on a couple of things, but otherwise I think we're actually working. Huh. Yeah, sorry about that, yada ba-boom. I'm much more Haskell than Scala these days. So let's see. So I started just before this. I have a new laptop here, so I figured I would break it in and write some Haskell on it. I have a bit of a project that's been sitting around for, I don't know, almost a year, which I've been debating about finishing up, which is to rebuild the distributive package based on a little package I have called HKD, which looks a lot like the Barbies package. Contemplation, it was almost exactly 4 years ago. Was the last time I managed to get up and set up on Twitch. So it's been a while. One thing I don't have working here is I don't have the Twitch chat popping up in the video stream anywhere, which means I will tend to respond to people with things that they will not be able to see later on if I ever record this and put it on YouTube. Hey, Emily. And congratulations on moving into the Haskell world. Let's see. Does ProFunctor 6 build? I'm just trying to see if all of this stuff can actually run on 9.4.4. Locathor, much the same. It has been way too long. All right, 944 doesn't seem to have broken too much. Well, above my head, there's a little bit of space. But you see these, the stage manager stuff? If I put more windows up there, then those will fill up pretty quickly. And then up here is where it will currently try to pop a notification if somebody follows or what have you. I can do a fake one right now as an example. Subscriber event. Woohoo! See, I got something going all the way up there. So yeah, so Math Nerd, I have some options about how to move it around. I haven't quite figured out exactly how I'm going to do this. If I put the chat directly behind me, it could work, but then the infelicities of not actually having a green screen behind me and just having fade to black and attempted auto segmentation will show more. I don't know which GHC it was between 9.2 and 9.4. I will confess I haven't been too current on what's been going in GHC since the 9.2 time frame. Let's see here. So constraints compiles, profunctors compiles. Let's see here. What do I want to do? I want to get fetch. What do I want here? I want to clone. This build. So when I had left off with all of these things, they were in a sort of limbo state of half trying to support the new API, and I don't remember where I left off. I may not get that far today, but I figured it would be worth it to at least try and get some of this up and running. Biff, bifunctors, what else do we have here? These all seem to be going cleanly. So either Ryan GL Scott or some other folks have been keeping all this stuff up to date, and it was only like 2 little changes I had to make in HKD. Yeah, there were like 3 changes. Git. Bumping a version on base, supporting current hashable, missing complete pragma, and then a couple of GEQ instances made it into upstream. And then safe and deriving via complain about each other, so I have to disable deriving via on a module that is explicitly marked safe. And that was literally the only thing I've had to do to get things up and running on 9.4 so far in the last 2 or 3 hours. All of the rest of these 3 modules went through safe. Trying to think of what else has been rebuilt on top of the new distributive. So let's see. So what we have. How's my audio coming through, by the way? Hello, Druffy. All right, then I don't need to worry. I have a Yeti off to the side. I've been debating about if I was going to try and use it, if I was just going to use the built-in MacBook speakers or microphone. But I think the MacBook mic is probably good enough. One thing that I had last time. Backbook. It's an audible fan or something. Oh, yeah. All right, well, I've got a pair of headphones that will be coming here in the next couple of days, which will get rid of the audible fan. And maybe I can adapt the mic audio a little bit to get it out of the red zone. All right, let me see if I can do that. Current noise filter. Do you know how to set that up, Locathor? Do I just add that to the scene? Audio input capture. I'll try and do it. Okay, then we need not do the audio input capture then. Let's see if I can just right click on filters on mic aux. Equalizer, compressor, expander, gain, invert, noise suppression. Let's try RN noise. Let's see if this helps at all. Testing, testing, 1, 2, 3. Or are we still getting the problem? Where is confusing.hs? Oh, confusing is a trick for automatically appropriately associating traversals. This is the if you say confusing traverse, it can often be more efficient than traverse. Yeah, I'm hoping that like a brand new MacBook Pro with all the bells and whistles can handle the extra noise suppression thing. So let me know if there's still a problem, but I think that might have just solved it. Actually, there was not an intentional pun. We had fusing, which was the version of this that worked for lenses, which was just the Yoneda lemma applied to the lens. And that would automatically fuse together the F map. And then we just found this one sufficiently confusing that we just went with the name. So, but yes, confusing is a better pun, and I wish I had thought of it at the time. And then index variance on the idea. So it's just built off of like a local alias for Create and Yoneda, because this thing is so far down in the package hierarchy now. It's in this little HKD package, which is the Barbie's like workhorse of all of the new distributive. These classes are more or less, if anybody's familiar with Barbies, they have like if we make a type alias for quote unquote natural transformations that aren't, these are polymorphic functions, from f of a to g of a. Then we can take an arrow that can turn an f of a into g of a that works for all a, and turn a t of f into t of g. The kind of things that you might have an f functor instance for would be like I gotta put an appropriate number of colons because it's Haskell. I'll remember how to write this stuff. And then if F was identity, you would have a normal employee. And if F was something like vec n, then what you would have is a column store representing 100 ages and 100 names. And F map lets you turn around, and if you have a way to map vec 100s into identities or something like that, then you can use this to convert from one representation to another. In general, I'm interested in Fs where Fs are representable. So a representable functor is something such that f of a is isomorphic to x arrow a for some x. And I will be using this f functor class in order to make that more powerful. Because previously we had distributive and representable in Haskell. And what this package goes and shows is that you don't need representable. Distributive has enough power if you make the right distributive. So we write down f functor, and then the contravariant equivalent of it, and foldable, and something that plays the role of something like traversable. Something like applicative or apply, and then applicative after we get around to building bind. This sort of fake F monad thing was due to Aaron Vargo. And then we've got versions of them with indices and stuff. But the purpose of all of that is to make this representable class. So we have a, something that you can take an f of a and get a log of f to a, log of f being the x that we talked about very briefly, and then tabulate being the inverse for index. So, and then there's a default log here because there's always a canonical choice of logarithm, which we can just kind of get at by looking at index having type f of a to log of f to a. Well, if I flip this to get log of f to this, that implies that maybe what logarithm should be that. And so that's a canonical choice of log, but it's kind of boring, and it's not very efficient in terms of machine representation. So what default log is trying to do here is it will take logarithm if it must. It will build it off of sums and products and things when dealing with sum types when dealing with product types and compositions, and it will try to get away with using a fin n if we happen to know what the size of this thing is, if there's only like 4 or 5 cases. And then tabulate tries to do the same thing to come back. The purpose of this was relative to the representable class. There's this god-awful scatter member, which we've engineered over some time here, that when put in the class allows a lot of things that are representable that people don't tend to think of as representable, like Mealy machines and Moore machines and stuff, to have better asymptotic performance when defined in terms of scatter rather than tabulate and index. And the real problem is that tabulate and index forces you to kind of pull the logarithm all the way out, to like convert all the way to some canonical form. Whereas scatter allows you to kind of do it one layer at a time. And scatter is the thing that's defined in terms of f functor, which is why this needs all that HKD nonsense. So if we take scatter and we replace these two functions with identities, then you get something like distrib takes a distributive f and an f functor w and pulls out of a w of f an f full of w of identities. And that's kind of a bizarre distributive law, but it's the one we get. So if f was a distributive functor, you got a w that's made out of many copies of the same shape, with different things stuffed in them. So I've got some kind of blob shape over here, my w, where it has, in this case, maybe like an array of names and an array of ages. And what I want to do is I want to convert that into an array of these blobs where these individual things have been replaced with identities. So I take these shapes that are inside of there that are representable, and I make one common representable shape, because representable functors only have one shape. So I can take all of these things and zip them up. And then I zip them up with all the other baggage that was in W. The problem with this is if I put this in the class for distributive, or this is representable, sorry. I just wrote this like this. Then since this class knows nothing about W, it doesn't know that W has a representable argument, generalized new type deriving would fail to let me derive representable instances. And so you wouldn't be able to use deriving via or anything like that, or GND, in order to make new instances. And that's a really powerful tool. So I want that to work. And so what I do is I use this little Yoneda-like trick to say, well, if you give me a G to an F, then I can fit that in here. I can F-map that when I'm in the process. I can FF map that when I'm in the process of FF mapping whatever I have to do in order to convert my container full of shapes into containers full of identities. And then the other one is because instead of having RBW of identity, often I will F map over this result. And it turns out that whenever I do this, I'm going to have to F map as the last thing I do anyways. So this gives me an operation I can just fuse into the other. So that's why this operation becomes this extra complicated beast. And then we get scatter. And this becomes an array. At least that's the idea. And then we have various ways of doing tabulation. One is if it's generic, we can use GHC generics for it. And otherwise, it might actually be, we can use a little pattern to do it. And then we can have different ways that we can implement it. One is we can use that logarithm type that we defined above, which was, or that I mentioned earlier, was canonical. We could use a fin-based version of it, or we could use rep for GHC generics. And then I just kind of try and define what the right logarithm is to use for a given type. The problem is if it's recursive, I can't necessarily use fin because I don't know that it's a finite thing. Well, if I ever recurse into myself, I'm screwed. So this gives itself so many tries to try and recurse. And then if it bottoms out, it will use the it can use the fin based encoding if it can get away with it. Otherwise, it will use rep if it has to, and logarithm if it's absolutely forced. Yeah, this is kind of a nightmare getting this right. So fortunately, I wrote all this before, so I don't have to do that now. And then there's how we do the distribution for logarithms and stuff like that. I've given a talk on this before. The last time I gave a talk on this was in Iceland. There is an implementation of a matrix library using representable functors. Funny you should mention it. That is what my linear library is. That's kind of the point of linear. So if we look at package linear, you'll notice that all of my vector types here are representable functors. A V2 here is representable. And I abuse that to make one of the combinators go. Let's see if I can get into the index here. underscore column. Oh, here it is. So here, if I index into a v2 of v3s and I access the x row, I will get this. I'll get this row directly out of it. But if I ask for column x, then I'll get this column out of this row major stored data type. And you'll notice that what I'm using is I'm using the ability of representable functors to lift over lenses to pull that off. Yoda boom. So this is literally about using representability in order to let me swap between lenses and between rows and columns. It's kind of nice because this also works for tensors. If you have a k-dimensional tensor, you can effectively do the equivalent of column. And then similarly, the way that we do transposes for matrices is done through using distributive. Now notice this was written before I started trying to collapse representable and distributive into one thing. So this gets away with using the simpler thing for computing the adjoint of a matrix. So yeah, it is kind of the original thought that made this library go. Now, Aaron Vargo would point out that what I did in this library was I said, I'm going to use representable functors where the representations are lenses, and that I put too much into that. And what I mean by that is if we look at, say, linear V3, there's a class, R1, that provides a lens for X. It's a lens that knows how to get an A out of T of A. And then for any V1 and V2, V3, this lets me pun the X dimension. And then we do the same thing for Y to pun to extract X and Y from V1, V2, V3. But Aaron pointed out to me at some point that what this really should be let's call it, I'm going to make up a name here. This is just a function that takes an f of a to an a. It doesn't need to actually be the full lens. It can just be the extraction portion of it, because this is enough to uniquely determine X. The rest of the machinery that comes along with it being a lens is too much stuff. And you can derive the rest of that from here if you have some way to enumerate all the individual fields. And so if we look at the notion of a logarithm and stuff like that, a logarithm is what really should have been the defining characteristics for these RNs in linear. Yeah, so these are uniquely determined, and there's only one of each one of them as long as you're working with representable functors. And then the nice thing about it is if you look at representable functors, they're always of the form x arrow a for some x, but this is a reader, a monad reader with x as the environment. So you get all of the properties you would expect from it being a monad reader, etc., which means you've got a join, which takes this thing and looks down the diagonal of this matrix. And you've got all the other kind of operations that you would expect. And those readers and stuff like that turn out to be kind of useful for just building functors out of this. So the motivation for that is that every vector space is a quote-unquote free vector space, and therefore it's isomorphic to a function from some basis to scalars. And so since every vector space is a free vector space, I just chose to use that as my representation of vector spaces in this library. Now, is it necessarily the best representation? No. Like for many applications, you do want something unboxed and what have you. But it does allow me to kind of make functors of functors of functors as tensors. And I did like that. So I shipped it. I don't know when did I ship linear? It was forever ago. In a language like Rust, this does optimize very nicely. In a language like Haskell, not as much. But it makes a good sort of lingua franca for like talking to like Haskell code on one side and things like OpenGL and stuff on the other. Because then we can provide all the marshalling instances and stuff to make that serialize as storable back and forth. This tab type is its own brand of crazy. Distributive collect. Let me make sure I undo whatever damage I've done here. This is all me just explaining stuff, not anything new. So tabulate takes a function from log f to a and turns it into an f of a. As a view pattern. The intention of this package was to get to where I could just say something like, hey, I want a more machine, and specify how to make it indexable and representable. And then all of the other instances should just follow. And then unfortunately, you can write them with slightly fewer constraints if you don't derive them. So I did it the hard way. But it is nice seeing most of the instances for a million more machines just kind of pop out for free from this sort of deriving via hook. What else do we have in here? Oh, this is like build a representable reader where f is a representable functor. So if the environment is a logarithm. This is kind of nice because you can actually get it to memorize things. I have a article on more machines for less. Which takes this encoding to its sort of logical extreme. I'll paste it into chat. I can't paste it into chat here. Weird. Oh, there it goes. All right. But yeah, the idea was to start with the fact that a more machine is a fixed point of a particular functor. And then to look at this encoding and see that we have a lot of S arrows inside of it, where S is something. It just needs to be, so I could replace this with a representable functor that's represented by S. Oh, bear with me. I'm still in the process of trying to get back into the Haskell swing of things. It's been way too long. I mean, everything here compiled, so I don't know that I need to do anything with this code. I was expecting there to be some massive rebuild necessary for the current GHC, but they didn't break anything on me when I wasn't looking. This test. I'll switch to my camera that doesn't make me look like I'm a troll in a cave. I had 3 lines of code I had to change. That was brutal. Test suite works. Okay, well, that was boring. Do I have tests in here? I don't think I have any tests in pro functors. All right, and this has all of my evil unsafe in implementation stuff. So this is a fin implemented as an int. So don't use this for numbers that are bigger than 4 billion. I had to bump base, and I had a warning because they changed some behavior on pattern synonyms. And then I had to fix another warning where it was complaining about deriving via and safe being on at the same time. Because safe Haskell was shoved into GHC 2022 or whatever it was. That's all safe. So what this package does is it starts with a fin as a machine integer, and then it cheats because I want this to be a small, like, int-sized thing. But if I, like, fin n is going to traditionally be built out of something like, let's say you had a data nat is 0 or suck of nat, with that actually made strict, then you would typically define fin n nat where you define like this monstrosity. The problem is this is going to be basically built like a linked list. It's going to be linear in its length in storage. So what I do instead here is I define, so we define this view-like type where fin is the machine integer one that we've got, and fin prime is the thing that looks like this thing locally. And then, where was it? So I've got my machine int base type here. I've got a nominal argument to it so that it won't let me cast it without complaining at me too loudly. And then I make this conversion that converts a fin n into a fin prime of n, which cheats by just unsafe coercing to these like view constructors. And then I provide a pair of pattern synonyms that say, in a context that knows nothing, if this thing matches, you now know that n is S of m for some m. And this uses the upfin conversion that hallucinated those constraints. And so that let me actually have this look like a GADT. And so we can construct a 0 in a context where we know this. And we can construct a suck of whatever when we already know that m or that n is of the form suc of m, and I already have a fin m. But at the end of the day, these are now actually working with individual machine integers. And then, of course, I have to actually reflect that with like some kind of known nat equivalent. Because sometimes it's actually important that when you're walking through the fin that you know what n is. And so we can give you smart constructors that preserve the known natness of each one of the steps. So what I like about this is whenever I would try to use like a fin n or something like that as like an index into an environment and a type checker, I would always feel dirty because I'd be using a linked list, basically representation of a number, to index into an array for my environment, or index into a linked list for my environment. And here it actually gets to be a machine int, so it's like if I had written the unsafe thing. But other than this one little module, it pretends to be safe. And as long as you go through the source numeric fin module rather than source numeric fin internal, then you get a safe API, and you don't even need to know that it's made out of a machine int under the hood. So yeah, this seems to have everything that I would want to package up in here. I had debated about using, there was an existing small fin package that was already built, but it had the obvious implementation, and I wasn't willing to take on the price of that for all representable functors for all of Haskell. So I decided I was just going to suck it up and write a more efficient one. And then if we look in HKD, there's a similar record type. This one indexes into a H list, giving back an int, and not just telling you that like we indexed into this array successfully, but that we actually found something with the correct type. And so this is like the fin trick all over again, with 0 and successor for like taking head and next, with the same index s properties. Do I have a known index s? I don't. And maybe the index s, index z, and index s should be I, z, and is, because the other ones were f, z, and fs. If I want to be consistent. I haven't shipped this code. No one can care about my. So if I go look at where that was in. So I need like an up node. What do we know about these things? Do we have anything that ever reifies this as a list of types? Maybe that's why I don't have a known is and known iz. There is nothing that just reifies a type list as a list of types. We get to know known length. So I've got up index. Known length A's. Index A's A to int. I need a type role for known fin prime, or known index prime. And that's going to take a I just get to know known length. Do A's gives me known index prime. This is not an index prime, it's a known index. BAC. There we go. These constitute much the same thing. This is boilerplate, and I hate it. Some nat of the proxy for n. Known length is known nat for length. N is SO. That much is about right. Unsafe. Index 0. This is known IZ. Index prime of I's is where do I get the O? That just asserts it into existence. Known index I is I. Save index n minus 1. Type known index prime I is I. We'll do the same inline only for phase 0. Up. Index. With that, I'll be able to get the known length of a tail of one of these things to work. Now I'm going to need another window here. Make sure that actually breaks. It's not breaking. Oh, numeric fin didn't change. It's HKD that changed. Derp. Case. $95. Known index. Oh, it's just index. Subnet proxy O. Where's my just or something like that I'm missing? Nat val. It's a subnet. In the case alternative, when is the expression that's busted? Let's do this again. Why does it think that's maybe some nat val? Oh, because it's now a maybe some nat. That would do it. When did that change? Back to that and look at nope, that one was still okay. Weird. Did this ever change? Was I getting by on the fact that I had a unsafe coerce? I think I was getting by on the fact that I had an unsafe coerce that really was unsafe. What do you think? Some nat val of nat val. Why is that? Why did this type check? Case some nat val of n minus 1. GHC typelets. Yeah, okay, that's what it might be. Is that they changed it in type nats? Some nat val goes from natural to some nat. Wow, that's a good catch, Liam. Yada boom. That's what I was working on at Miri before I left, but then I went off and did a whole bunch of work at Grok, and now I'm doing other things. So unfortunately, I don't have typelets. Let's do this, and then I've got the. Where am I? HKD. Is there a nat val that's also natural based in there? And I need I need to do this in a different order. I need eyes to be J colon eyes. And then we can say, no, not eyes, J colon J's. Length of eyes should be equal to successor of length of J's. Do it this way. So it just hallucinates that fact. These are pulled out of my ass. Type index eyes. Should all be fine. I just didn't have that indented correctly. Now an index into eyes. I. Eyes is I2. I'm going to need to do this again. Let's see. Whatever happened to the succinct data structure stuff I was working on way back when? That largely got picked up by John Gee and those folks. So Haskell Works wound up shipping a version of that. As for the tricking the JVM into compiling our Haskell code CEK VM thing, so what I was doing there was just sort of generally trying to figure out like how do I run functional languages, not necessarily Haskell per se. And I got it up and running. And then later on, um, there's a startup called enso.org, which took some of those ideas and some of their own and built a little Haskell-like language. That's a visual programming language that's designed to run on the JVM. It's kind of going after the Alteryx market. And they took that and are still doing stuff with it. So I was doing some work with them last year to try and get them up and running. But it was more Java than I was really comfortable with, and a combination of health reasons and available time kind of wound up wrapping that a little bit earlier than I would have liked. Known index i's j. I's I2. So you got a known index i's I2. I should be the variable that's in scope. That should be true. J const on 2. Oh, this I need to know. Here I need to know that they're the same. Man, this is getting really... We're hallucinating like 3 different refles. J is I. And I need to know known net length I. And now I need to hallucinate the new known nat. This isn't O. This is proxy length of J's. Where do I talk about N in here? Nat val length of i's minus 1 will be magicked into proxy for the length of j's. Call that proxy n. This is really filling me with confidence. Refl is n is length of j's. This is just random crap that I left when we were talking earlier. I didn't actually build those patterns yet. That was hideous. It only hallucinates 4 constraints. Known length eyes. And then eyes is J const onto J's. And this is a pattern on index eyes I. You need to repeat this for known IS. Yeah. And now we've replicated the functionality that was missing from fin. I probably could have just done it with lift and lower fin, but Online partial evaluation. Yes, quite a bit. A couple of things here is one of them is using. First of all, I use partial evaluation a fair bit. Representing, but not actually. Hello, new made Yamosa. There's no abstraction here. This is all very low level, horrible system hackery. Look at that. It's an actual integer. It's an honest to God type. When do you see one of those in my code? Well, whenever you do, it's all going to be unsafe coerces and me lying to the compiler, but and then I need a total pattern for this. There we go. Did I use lower case complete for the previous one? I'll use lower case complete for this one. Fine. Known length is there. Length is there. Index is there. To index. Lower fin, lift fin, and length. And then if I go down into here and I just pull up index of HS, now this was distributed was sitting on top of this. This probably broke. Because I'm sure I used the word index somewhere, or index IZ and index IS somewhere. Or IZ, index Z and index S. Do I do any coding in Rust? Actually, a fair bit. I've written a lot more Rust lately than I've written Haskell. In particular, I find Rust to be quite nice when dealing with various forms of incremental programming. I am a very rusty Haskeller right now, yes. My Haskell skills have fallen to the wayside. This is forcing me to pound off some of the worst of the Rust. It's just generic spec crap. Yeah, the main thing I'd use Rust for is I've been playing around with a bunch of incremental programming techniques based on something that went into, I think, the first or second thing I ever streamed, actually. I think I streamed authenticated data structures in Haskell in my first or second stream. And they turn out to be a very nice framework for doing incremental programming and for doing a somewhat better FRP framework than something like Reflex, because you can come up with an FRP framework that does less recomputation. And an example would be like if you think about something like Reflex, where you basically have the ability to create variables that you can watch, and you have thunks that can watch those variables, and then when they get any of the input variables are changed, the thunks unevaluate themselves. The problem with that is consider something like, let's say you have a thunk, like a variable that contains the string foo, and you have a thunk that's going to compute its length, and you switch from the string foo to the string bar. Well, that thunk gets invalidated, and everything that depended on that thunk got invalidated, even though you respected that quotient. Like foo and bar have the same length. So Reflex will be too eager about flushing everything out of the environment. And there's ways that you can actually turn around and flip things on their head so that it's still demand driven. So you can't just compute the new length and then see if you should invalidate everybody downstream of you, because that wouldn't be work safe. You would actually change the termination behavior of your program. Yeah, Rust Analyzer, etc., is generally better than the GHC equivalent at this point. I fully agree, Harold. What did we get done? We got distributive, we got profunctors. I don't need anything there. I don't need anything else. So all I did was tweak index and HKD. I didn't do much. Get a HKD index. This is the safe version of the API. These are indices into type level lists, except they're represented by an actual integer. All right, those are good. I suppose we're tested now with GHC equals 9.4.4. This is me deliberately trying to change my style to see if I can bring myself to stomach using default extensions. I have not historically done this. I reserve the right to revert. Yeah, it looks fine. Look at all those tested widths. I totally tested, right? You watched. I ran the test suite. That will probably break Ryan GL Scott's careful build bot stuff. Sorry, Ryan. Main thing that changes in the new version of profunctors is that Cayley and Tannen become the same construction. Because in this version of profunctors, we adopt quantified superclass constraint, or we try to. This is me picking a fight with GHC. And I would like to do the same thing for bifunctors, but I made the mistake of standardizing it, and it went into base. And so now I'm stuck in limbo. So in the new bifunctors package, when I go to build bifunctor functor and all this kind of stuff, I have to build this little bifunctor prime type, which is lame. It really should just be bifunctor, but it's bifunctor with the quantified superclass. And the reason is because then I can actually have bifunctor functor and all that kind of stuff, just like I do with profunctor functor. And that lets these two things kind of come into parity. But then I have to refer to bifunctor prime and bifoldable prime and bitraversable prime everywhere until we can get base to include the quantified superclass constraint, which is lame. I guess this isn't 4.8 to 15. This is um, was it 4.17, 4.18? Ubuntu 18.04. I feel old. All doc spec checks names chunked. Okay. What changed here? Something inverted. It's been so long since I did this change, now I don't remember. I think I removed the distributive stuff from here and I moved it into the distributive package. That's what happened. So this moved down in my package hierarchy. And I can see that if I look at the original. Yeah, this has distributive as a superclass or a super package. And it has a bunch of other stuff. And in the new story, base, tagged, transformers, containers, index, traversable. Containers, no distributive, index, traversable. Semigroups has aged out of being used. Tagged is still there. For proxy, I'm guessing, so that's not needed anymore. Transformers and transformers compat. Okay. What version number are we on? This is version 6. All right. How do I get to lens? We got a lot of stuff to get between here and that here and lens. I also might run out of steam here. We've been going for an hour and a half.